Hi students, so my name is Shiv Hari Tewari and currently I'm working as an assistant professor and talking about my specialization. So I have done MTech in computer science and engineering where my uh, specialization was in artificial intelligence and machine learning. So today we are going to learn about the basics of machine learning and here I'm going to teach you about some basic concept as it is a part of your first chapter only, the first module. So the introduction to machine learning, that's what we are going to learn to know about today. So let's move on further. So when we are talking about machine learning, the machine learning contains so many things. Like it is like a broader domain, I should say. Nowadays it has become broad domain of computer science branch, and when we are talking about the job opportunities and other things in machine learning branch, so we have got various job opportunities in like machine learning developer. Then there are some data science opportunities as well in machine learning. So it is like a buzzword of now of day to day society now, when we are talking about our corporate world as well as in IT sector. Now, if I tell you what is machine learning, so most of the people will tell me that it is like training our system, or it is like when our computer is respond is become when our computer becomes responsive to us. So it is an application of machine learning where our computer becomes responsive to us. But when we are talking about machine learning, uh, in a layman's term, or if I talk about like the definition of machine learning, it will goes like that, when we that it is a branch of computer science where uh, computers are enabled to learn from data and experience without being explicitly programmed, which means we are training our computer with the help of some data, with the help of some training sets, with the help of some training data, and from that we are going to make our computer, I should say, uh, an experienced an experienced computer, or I should say, an intelligent machine. So that this is what a definition of machine learning in a layman's term. It is like we are training our computer, or like we are making our machines or making our computer more and more intelligent. Now moving on further, when we are what we are going to learn about in our objectives. So it is today's objectives are, uh, first one is like brief history and importance of machine learning. Then second one is what is the role of data and connection to the knowledge and experience in machine learning. Third one is like successful examples of machine learning in industry as well as in like working society. So here we will going to know about like what are the successful examples of machine learning, what are we using machine learning in our day-to-day life. So these are like some few of the examples that we are going to see. Now moving on further, what we will going to know about motivation and role of machine learning in computer science as well as in problem solving. So see, problem solving is part of AI as well. When we are talking about artificial intelligence, problem solving has been coined from there only. When we that there are some agents, when we are talking about like problem solving agents, then uh, there are so many types of agent like problem solving agent. Then there are uh, there are like so many types of agents which we are going to know about, yeah, artificial intelligence. But since it is machine learning, so we are not going to learn about the agents and other things. But it is a part of machine learning as well, problem solving. And then there are goal based agents. Then there are like various types of agents in artificial intelligence, and like machine learning is a part of artificial intelligence itself. When we are talking about agents, or when we are talking about problem solving, when we are talking about algorithms, so these all are the parts of artificial intelligence as well as machine learning. So machine learning algorithms are different, as well as artificial intelligence AI algorithms are different. But on the if we are talking about broader perspective, so we can say machine learning is a part of AI. So in a layman's term, we should say that AI is a broader domain, or we should say AI is like an umbrella term which includes deep learning, machine learning, then some supervised and supervised learning as well. Then there are some shallow learning as well. So when we are talking about learning, so learning is intelligence when we are talking about learning, it is like intelligence gets developed when we learn from our experience. So this is how this learning term goes on. Now next one is which we are going to learn is which we are going to know is like connect machine learning to broader theme of computer science. Like what are the other themes of computer science? What are the other branches of computer science which uses machine learning algorithms? So like these are some basic, these are the topics that we are going to learn. Moving on further. So before moving to machine learning, we should know about what is learning. If I say learning, or if I say that person has learned from his experience, or like if I should say that a student is becoming is improving its performance. So what does it indicate? It indicates that particular student is learning from his past experience, his or her past experience. So if we talk about learning, learning is a process that leads to change, which occurs as a result of experience and increases the potential for improved performance and future learning. Which means if there is a person, doesn't matter if he or she is a student or working professional, or if or anyone else, how he or she is going to make his or her performance better is from from their past experience. So in their past experience they have done something wrong, some mistakes. Of course, when we are trying to do something new, or if we are trying to start something, mistakes and errors are like inevitable. So from their mistakes, from their error, from their experience, they will improve, and that's how they learn from their past, or I should say their experience, and that's how their performance gets improved day by day. So this is what is defined as learning. Now when we are talking about machine learning, so when so in machine learning there are two things. First one is like learning part, where we are going to use learning, and we have used machine with that. Now when we are talking about machine learning, that means we are training our machine with the help of some data, or I should say training data. So it is like we have used some kind of training data from which our machine gets trained, and it gets experience from its training data. And after that we test that machine learning model, or I should say machine learning algorithm, whether it is trained properly from its training data or not. So there are two things. First one is its training data, and second one is testing data. Now what training data does is, here training data is used to train our model. I should say, if we are making a machine learning model, if suppose that this is a model, so training data used to train the model, and where we and in that kind of in that training data we have used like it is always bigger in size. Like when we are training the model, the training data can be in size of like 1.2 GB, 1.3 GB. Sometimes it can be around 40 to 50 GB as well when we are working in industries like in Pfizer and Tata. So when they are deploying their employees on the particular project, so these projects, when we are working on data science, so they will provide us like the data set of like around 40 to 50 GB, which is uh, later partitioned into smaller subparts, and various data scientists, various data analysts will work on that data set. So in training data, what we are doing here, what we are doing, we are using training data to train our model, and after that we use testing data to test whether our model is performing better from its predecessors, or like if there are any currently created models and we are creating a new model, so we are going to compare its performance with its predecessors, or like the models which are previously created, and then we measure its performance, and then we will say that our model is trained, or I should say that our model has learned from the training data, and now it is a trained model and it is working better than its predecessors. So this is like an explanation for machine learning. Now if we talk about what is the definition of machine learning, so it is a field of study that gives computer the capability to learn without being explicitly programmed. That means we don't need to program our computer explicitly, or like our machines explicitly for a particular task. Like if I say that we need to forecast the weather, or if I say we need to forecast the share market, or if I say that we need to predict whether if I say whether which team is going to win on the basis of its previous performance, or like if I say that which student is going to perform better on the basis of his or her previous performance. So these are the tasks which is based on prediction, and for that we don't need to explicitly program the different models or different machines for that particular prediction task. So what we will do here, we will take one training data for the prediction, and after that we will train the model, and then once the model is trained, and once the model is performing its task better, or once the model is performing its task uh, precisely, in that case we are going to give it like other data sets, like if a model is performing uh, same results on the share market forecasting, then there are chances that the same model will perform better on the weather forecasting data as well, and there are chances that the same model will perform better on the student data as well. So if I say that without being explicitly programmed, what is the meaning of without being explicitly programmed? That means we don't need to we do not need to train the three different models for the three different data sets. We need to train one model with the one training data, and from that one training data only the model will perform the same task or the same prediction process to the other training data, to the other training data sets, and for that we will need to like some data pre-processing parts and other things. So we will learn in our later run, when we are going to learn about what is machine learning algorithms, what are the types of learning. So this is the definition of machine learning. I hope it is clear to you. Now moving on further. So let's talk about the importance of machine learning. So it is like the next topic which we are going to discuss about. So when we are talking about what is the importance of machine learning, so uh, like when in our like when we talk about like 2001 or 2002, the year 2001 or 2, there was weather forecasting system, and that weather forecasting system will work with the help of statisticians. So what statisticians were doing at that time, they used to like take the data set for like if there is rainy weather for the last 20 days or 30 days, and on the basis of that data set they perform some tasks, they calculate some root mean square errors, or like they calculate some accuracies, and after that they predict whether our whether the uh, the season, or like whether the weather of upcoming days or upcoming week will be uh, rainy or windy, or like normal sunny day. So for that we had to do we had to take the help of statisticians, or like our mathematicians for that. Now here the first one is automating process. Now what it has done here, in the instead of doing those tedious tasks with the help of some statistics formulas, or with the help of uh, some calculations, instead of doing those I should say uh, calculations, or some tedious tasks, we have just used some algorithms, and these algorithms has already involved these kind of calculations, like machine learning algorithms, which like if I need to uh, forecast tomorrow's weather. So for that, I only need to take the data set which is already created, or like there is a training data. All I need to do is apply some kind of some algorithm, some machine learning algorithm to train our model, and that model will forecast the tomorrow's weather as well as the weather of upcoming week or upcoming month as well, on the basis of given data set. So here what it has done, it has automated the process, and machine learning can automate tedious or repetitive tasks, freeing up time for more complex problem solving, which means it has freed up the time of human beings, or like you and me, to solve more complex problems which are already available in the market, instead of just doing some random calculations which is too basic for the human brain or human mind. So if I talk about today's market, or if I talk about now, if I talk about nowadays ongoing thing, like there is one thing called Chat GPT. So what ChatGPT is doing, ChatGPT is writing your basic programs. If we need some kind of program, like if I need a program in Java to add for the summation of two numbers. So instead of uh, using our brain, or instead of just wasting time on those small problems, we can just ask chat GPT to write us a simple program, and it will write that program for us. And even it can write I should say your content. Even it can write your essay, as well as your other things. If you want to if you want to write, if you want, it can write a poem for you. So basically what it has done, it has uh, I should say it has done the shrinking of human efforts. So here we can see that there is that what is happening here, the shrinking of human efforts is going on. Like human efforts are getting lesser and lesser day by day. So we need to solve the complex available complex problems uh, for to make our machines more and more intelligent. So first thing is automating the processes, which has done by machine learning, or I should say which is an important aspect of machine learning, where machine learning can automate the tedious or repetitive task, where and it can free up more time for us to solve the complex problems. Second one is improved accuracy. Now if we talk about our previous year, or like if we go back to last decade, or if I go back to 2008 or 9, there was a time when they used to do some weather forecasting, and there could be the possibility that if they have predicted that tomorrow will be a rainy day, but when we woke up early in the morning, we see that there isn't any kind of like raining, or like the weather is like more and more sunny, or some windy kind of weather. So why is it happening? Because humans, whether we are working on ERP, whether we are working on some kind of like ledger sheets, humans have tendency to make errors. On the other hand, if you talk about machine have this tendency that they are tend to make less errors than human. So when we are training our machines to do some particular task, there are chances that our machine uh, can give us lesser errors than a normal human being. So for that, we can say that another important aspect of machine learning is that it can improve the accuracy of the result. If I talk about like by learning, like here it is written, by learning from data, machine learning algorithms can make more accurate predictions and decisions. Now here it is saying that when we are training our model, machine learning model, if you talk about like it is a data set, and suppose that it is a model. Now, if our data set is trained from this model, if our model is trained from this data set, there is a lesser chance to give errors, because and it has there are more chances to give much accurate predictions than human beings, because it has trained from the pre-processed data, which has already removed its null values, its missing values. And on the other hand, if you talk about humans, so sometimes we can ignore, sometimes there are some chances where human beings, or if I talk about like statisticians or scientists include one or two missing values, and which can cause a lot of I should say it causes uh, it causes a lot of errors in our accuracies, as well as if we talk about other end results. So humans have tendency to make errors, but machines have lesser tendency to make errors. That's why we have switched to training our machines instead of investing more and more time to human beings. And we have and instead of doing the basic instead of giving basic works to the human beings, industry has decided to give more and more chance to machines. So the second aspect is improved accuracy. Third one is discovering new insights. Now, here it is saying that machine learning can reveal patterns in data that humans may not have noticed. Now, when we are talking about a data pattern, so pattern recognition is one of the most common aspect of machine learning. So, if there is a data set of student, or if a data set of class, and if we have trained a model to analyze that data set and give us some like exploratory data analysis results, there are chances that machine learning can give us some trend analysis for the student. And suppose that if there is one student which has gradually which has a which has a performance which is improved gradually, but uh, as a teacher, or like if there is a teacher which who cannot observe that, but there are chances that machine learning from the trend analysis can easily observe that there is a particular student whose performance is improving gradually, and there are chances that that student can get better marks or like highest marks in some particular subject on the basis of its trend analysis. So machine learning can discover a new insights, and those insights can be easily ignored by humans. So this is like another aspect of machine learning. Now the fourth and final aspect is scalability. So when we are talking about scalability, so scalability is like when we are working on some application based programming, or when we are working on like uh, some bigger applications. So in so some bigger so those bigger applications have tendency to uh, like those applications should be scalable so that we can add some extra features. Now uh, in our previous decade, or I should say when we are working on Java, so Java programming has that tendency to make more and more scalable applications. But when we are talking about machine learning, this scalability feature has been involved in machine learning by default because of its nature to get improved result with the help of with the help of changing the data sets, or like with the help of improving or pre-processing the data set. So with the advancement of computing power and data storage, machine learning can be applied at a scale to solve larger and more complex problems. So we can train our machine learning models, so we can train our machine learning algorithms to solve bigger and bigger problems. So we can say if there is one algorithm which can solve, suppose that one algorithm can solve some basic mathematical problem like summation, subtraction, addition, and multiplication. So we can train that particular algorithm or or that particular model to solve bigger problems as well, like when we are talking about integration, differentiation, or like statistical operations. So we have algorithms, we have libraries for in machine learning which can basically solve those kind of complex problems which are already given, and which cannot be solved by human beings in a lesser amount of time. So scalability is one of the important aspect of machine learning. So I hope this topic is clear to you all. Moving on further. So next one is, what is the role of data in machine learning? So when we are talking about in our previous so many in our previous slides, I have already talked about training data, testing data, data sets. I have repeatedly used these words. So why have I used these words? Because when we are talking about model, when we are talking about machine learning, when we are talking about the training of our machine, we are going to train our machine with the help of some training data. Like as a human being, we get trained, or we get experience from our previous incidences. Like if I talk about as a human being, we can learn from our previous incidents of life. So similarly, uh, the machine or like the models of machine learning learn from the data sets, or I should say the data which is given to our machine learning models. So it is said that if I talk about the data sets, so in that case there are some more and more branches for only for the data set preparation, data set data cleaning, data test, data analysis, data pre-processing. So there are so many branches for only for the data preparation part. Now what is the role of data in machine learning? First one, it is saying big data. Now when we are talking about big data, so this term has been coined after the social media like Facebook or Instagram or Snapchat has become viral on the internet. So once the people once people got totally dependent on like the data part, or like our applications. Like if I talk about Google Drive, so G Drive contains like billions of data of like world population. So why is it containing? Because there is a possibilities that humans are most of the human beings, or like most of the people rely on Google Drive, because they are not able to carry the whole hard copy hard copy of their documents with themselves. So for that, they tend to upload their data. They tend to upload their mark sheets or like their documents on the Google Drive. So this is how the term big data is coined and created. So big data is basically the large amount of data set which is generated from the platforms like Facebook or Instagram or like some Google clouds. So for the big data we have for the big data we have further created some more clouds like Google Cloud Engine, Azure, then there are Amazon Web Services. So these are like our big data part. Now what it is saying is machine learning algorithms require significant amounts of data to learn from in order to make accurate predictions. Now why is it saying that large amount of data? Because not large amount, it is saying significant amount. So if I say significant amount, what does this mean? Can we is there any possibility that we can predict tomorrow's weather from the today's date from the today's data, or like from the 1 week data? So there is a possibility that we cannot predict the tomorrow's weather for the today's data. Or if I talk about like uh, stock market predictions, so stock market is a very volatile, if I should say about stock market, it is a very volatile field. And as a volatile field, I should say there is a possibility that one company whose stocks are going upwards today, there are possibility that tomorrow their stocks will go down. So for that we need a large amount of data, or I should say the data set which contains some historical historical content, like that contains a large amount of content where it contains like when the stocks are going up, when the stocks are going down. So to train our model, we need one large amount of data set, and for that we can train our model to perform better on the testing side. So to train the model, we need significant amount of data, and for that we need the big data. And that's how the role of big data is. That's the role of big data in our machine learning model training. I hope it is clear to you all. Next one is data cleaning. Now, in our previous slides, I have used this word repeatedly, which is data preprocessing. Now, what is data preprocessing? If I talk about preprocessing, so preprocessing is basically when we are talking about preparing our data set. So preprocess means it indicates that the data is going to be get prepared for the training as well as for the testing. So the data preprocessing part, the data preparation part, and where we prepare the data, where we remove some missing values, where we remove the null values from the data set, where we remove some kind of like garbage values which contain some signs like asterisk or other things. So these all things comes under the data cleaning part. So here it is written, before data can be used in machine learning, or I should say it should be here is machine learning training, model training. So before data can be used in machine learning model training, it must be clean and pre-processed to remove errors and ensure consistency. Now, if the data is not clean, or I should say if the data is not pre-processed, what will happen? The model, or I should say the output will contains outliers, and it could be like overfitted or underfitted output. And we will learn about that later. There are two terms, overfitting and second term is underfitting. Now, if I talk about these two terms, like overfitting contains those information which are not necessary for the prediction. So when the training of model contains some unnecessary information, or like takes some unnecessary information from the training data, then the result can be said that there is a overfitted result. And overfitted result basically leads to some higher level of inaccuracy, while underfitted result is where the training data or the model has or where the model ignores the training data part, or I should say the important data points which are needs to be taken but got ignored by the model, is known as underfitting. So these are the two terms which we are going to read further in our supervised and unsupervised learning part when we are going to uh, learn about them as a chapter or as a topic. So I, I I was back to that. I'm coming back to the topic. So what is data cleaning basically? Before the data can be used in machine learning model training, it should be cleaned and pre-processed to remove errors. So to remove errors or to ensure the consistency of our model, we need the data to be pre-processed, to be cleaned, and to be prepared. So that this is why that is the role of data cleaning in our machine learning model training. Okay. Now the third one is data labeling. Now, if I talk about the data labeling, labeling of data means to classify our data into further categories. Like if we have the data set of one batch, like there is a batch of BTech computer science. Now BTech computer science is a broader category, and in that broader category there are some students who are achieving A plus grade. There are some students who are achieving B grade. Then there are some students who have who have got the backlogs in their semester exams as well as their internal tests. So these are the categories of students. So to train our model, or I should say to train the to use the data in the machine learning, we need to classify component of data with the help of the data labeling part. Like there are some process which is called the data annotations. So data annotations are used to classify and label the data into particular categories. So here it is saying for supervised learning, data must be labeled with the correct outcomes so that algorithm can be learned by the machine learning model. So machine to make our model more and more trained and to make our model perform more and more accurately, we need to classify the data. We need to label the data accordingly. So I hope this point is clear to you all. Now moving on further, it is a next point is connecting knowledge and experience to machine learning. Now first one is learning from experience. We all, like as a human being, we all learn from our experiences. So just like human, machine can learn from its experience and improve their performance over time. Now how can machine learn from its experience? If we suppose that we have created a machine learning model, okay? One model can be trained from one training set. Suppose that there is a training set T1. Now it has suppose that it has performed with 85% accuracy. Suppose that it has performed with the accuracy of 85%. Now suppose that now again we have used the same model with another training set. Suppose that there is a training set called T2. Now, if the model has performed 95% accuracy, there are chances that the model has improved its performance with the help of its past experience, and it has removed some kind of it has removed some kind of thing which do not need to be involved in the training process as well as in the testing process. So that's how our model gets trained with the help of particular data when we are giving too many data sets of the similar type again and again and again. So in that case, our model learns by the time, and it performs better over the time. Okay. So that's how our machine learning model learns from its experience. Now, second one is transfer learning. Now, transfer learning is a very important, or I should say, very necessary branch, or I should say, it is a very important aspect of machine learning, where we can transfer our knowledge, and we can solve so that our model can solve the problem efficiently. Now, when we are making a model, so suppose if I'm suppose that making one model, suppose that it is a model called M1, and if there is a previously created model M0. So if I need some kind of experience, or I need some kind of if my model M1 needs some kind of knowledge, some kind of training from the previously created model, we can directly call M0 to M1's programming, or I should say the programming in the programming code, or in the code of M1 we can directly call M0, and that M0 model, suppose that it has this model is created, and from that M0 model, this M1 model can be directly trained and can learn more and more efficiently. So just like humans learn from each other, models are also learning from each other in machine learning. Third one is human in the loop. Now, machine learning can be combined with human expertise to create more accurate and reliable models. What does this mean? This means when we are talking about machine learning algorithm, or if we are talking about the training of machine learning models, all the training processes, all the machine learning training models involves human expertise, or I should say, the human hand to get trained in a better way. So there is a possibility that without human being, there is a chance that model can maybe the model can get trained without the expertise of human, but there is a chance that kind of models, or like those kind of algorithms, can give us some kind of overfitted results, or most of the time they give some underfitted results as well. So machine learning model has one more aspect, that it always connects human in the loop, so that they can perform better, or like they can get trained better. Okay. Now final one is adaptive learning. Now the last aspect of machine learning is machine learning can adapt to changing circumstances and new information. That means, suppose that we have created one model M, or I should say that it is a model M2. Now we can improve M2 with the help of M0 as well as M1, and from that, and we can use M0 and M1's algorithm as well to make M2 adopt the new type of data set. Suppose that M0 and M1 has tendency to work on mathematical data, not some kind of character based data sets, or like the data set which doesn't have many categories. But we can train M2 with the help of M1 and M0 as well to involve the speciality, or I should say that to involve the property to work on character based data, as well as like the data which contains some kind of categories. So this is how we can say that machine learning models have the tendency of adaptive learning. So I hope this point is also clear to you all. Now talking about successful example of machine learning. So it is saying that first one is online advertising. So when we are talking about if you have suppose that you have searched on the Google that you want to buy a new pair of shoes. Now you have searched on the Google that you want some new pair of shoes, and you are getting the I should say advertisement of shoes on your social media platforms like Instagram or Facebook. So how is it happening? Because there is a machine learning algorithm which is working as a recommendation system, which provides you, or which gives you the advertisement, or examples of the available pair of shoes which comes in cheap and best. So that's how in the online advertisement they are using machine learning algorithms to perform their advertisement industry better and better. Now second one is speech recognition. Now what is speech recognition? It is to, I should say, in speech recognition it is using for text to speech, or I should say it is used to take command from human. Like if I tell my, if when we say, hey Siri, what is the time? Hey Alexa, what is the weather today? So how is it happening? Because Alexa has I should say Alexa has a property of speech recognition. So speech recognition is one of like one of the successful example of machine learning. And if I talk about Python programming, when we are going to study further in Python or like Java, there are many libraries. Like there is one library called Google Speech Recognition in Python, which is created by Google itself, and it works like just like our Google Voice Assistant. It gives us like reply response, as well as you can program it, and you can use it in your own Python program and create your own voice assistant with, and you can name it something like that. So there is one fictional example as well, like if we talk about Jarvis of Iron Man. So these are like some successful example of machine learning industry. Third one is medical diagnosis. Now, when we are talking about medical diagnosis, there are possibilities that we can nowadays we can predict if someone is having tumor which is cancerous, or like if someone is having any kind of disease. These diseases can be easily identified with the help of machine learning algorithms, because machine learning algorithms machine learning models are trained from the given data sets which are already which already contains the symptoms, or like their uh, all kind of like symptoms and diseases. So for that, from their previously from their previously created data sets, or from the training data, they get trained, and by that they can perform better and they can diagnose the disease. So there are a few examples of medical diagnosis. There is one unit plus plus architecture which is used for cancer patients as well, or brain tumor patients as well, to to identify their tumor, whether it is cancerous or non-cancerous, and they also use the categorization and classification algorithms for that. So these are like some successful examples of machine learning algorithms and machine learning models in the industry. Another successful example is text analysis. If I talk about now text analysis, what it does basically. Suppose that in Amazon there is a product review, and in product some user has commented or like reviewed that the product is not good. So from the text, the machine learning algorithm can easily identify that the person is having a bad review, or person is giving a bad review for their particular product. Similarly, there is another example of sentiment analysis. Sentiment analysis. Then also there are facial recognition is one of the successful example of machine learning. Facial recognition. Okay, so like these are some successful example of machine learning in the industry which we are using nowadays. So I hope this point is clear to all of you. Moving on further. So next point is motivation and role of machine learning in computer science. Now, what are the broader mottos, or I should say, what are the broader targets of machine learning in computer science? So first one is creating intelligent system. Now, what are the intelligent system? Intelligent system comes from, see, this term intelligent system, or like intelligent devices is basically coined from the term from the AI branch. Now, it has says that machine learning, it says that machine learning can be used to create intelligent agents that can reason about the world and make decisions in complex environments. Now, what are the intelligent agents? If I talk about AI, there is a term called AI agents that you will study in AI as well. So, what are the AI agents? AI agents are basically those programs which are used to perform the particular given task. Like if you have watched this movie called Matrix, The Matrix. In The Matrix, there is a person called Agent. So what Agent Smith does is basically its major target, or its major task is to remove those kind of programs which is going to be rogue in the system. Like if there is a if world is a computer, so Agent Smith is a program which is used to remove all kind of rogue software, or rogue programs which are there. And one of the rogue program was Neo in our Matrix movie. And Agent Smith was a goal based agent which has used its ability to remove the program from the given matrix or from the given computer system. So that's how intelligent agents work in our machine learning environment as well as in our AI environments. So they are given the particular task, and they are performing their task and then give some kind of results to us. Second one is increasing efficiency. So by automating tasks and optimizing processes, machine learning can improve efficiency and reduce the costs. Now, if I talk about increasing efficiency, so when we are talking about, like in our previous slides, I have told you that humans have tendencies to make errors, and machines have lesser tendencies to make errors. So that's why people are relying more and more on machines to increase their efficiency, to perform the task better and in an optimized way. That means uh, machine can perform the task with lesser errors, and in the lesser time than human beings. So it can improve the efficiency as well as it can improve the cost to company. Like if we are talking about one company is paying 10 employees for the particular statistics calculation, and instead they have given those tasks to 10 to one machine, and that machine is doing the task of 10 statisticians. So it has reduced the cost of company as well as it has optimized the processes, and it has improved the time efficiency. So it has made the process time efficient as well as cost efficient as well as optimized. So that's how machine learning. This is one of the aspects of machine learning to increase the efficiency in industry. Third one is advancing research. Now we are when we are talking about machine learning, there are more and more researches which is going on in our day-to-day life, which some of them like imposing dialogue system, as well as there are some other machine learning algorithms which are used to uh, predict some kind of like disease, as well as there are machine learning algorithms which is used to predict which is used for the prediction of space events. And so it is used for the so we can say that machine learning algorithms can be used uh, for the advanced researchers as well. And even today the geoscientists or the astrophysicists are also using machine learning, and they are learning they are studying machine learning to improve their performance in the astrophysics, as well as they learn Python too. So that's how our machine learning is going to be used in advanced research part as well. I hope this point is also clear to you all. Further is connecting machine learning to the broader theme of computer science. Now, when we are talking about connection of machine learning, so there are three examples that is given here. First one is artificial intelligence. We all know artificial intelligence, like machine learning, is a subfield of AI that focuses on creating systems that can learn and improve without learning being explicitly programmed. Like it is a definition of machine learning. Now, when we say when we say what is that machine learning is a part of artificial intelligence, that means AI is like one of the theoretical branch of machine learning, where we are going to uh, where we are going to like create a transition, or like do the calculations or know how uh, states of a machine works. But when we are talking about machine learning use the application of those AI theories in the algorithmic part, like in a computing, when we are computing the algorithms, or like when we are computing the theories of AI. That is where machine learning comes into light. So that is how we can connect the AI to machine learning. Second one is data science. Now, when we are talking about data science, the data science is one of the umbrella terms that we are using. Why? Data science involves data engineering. Data science involves data analysis. Data science involves prediction. Data science involves data pre-processing. Data science involves statistics. Data science also involves the mathematical processes, like when we are talking about algorithm improvement, when we are talking about like creating a new model, creating a new algorithm. So these all things comes under the data science. So the data science is like an umbrella term for all the machine learning processes which we are going to use. Okay. So that's how our the data science is connected to machine learning. Okay. Third one is algorithm design. Now, with the help of machine learning, like one of the most important aspect of machine learning is pattern recognition. So with the help of machine learning algorithms, we can use to find patterns in the data, and we can make predictions, and even we can create a better decision system which can give us like decision to do some tasks which are much more confusing to human beings. So for that, we can create a better algorithm. We can create a better decision system with the help of machine learning. So I hope this topic is clear. This point is clear to you all. Next one is the history of machine learning. Now, when we are talking about history of machine learning, in 1950s, if there is a term, it says in 1950s the birth of AI. Now, it was not the birth of AI, if I should say precisely, in 1950s, or I should say in the early 1960s, not 19. It was after 1955, and there was a professor called Professor John McCarthy. Now, Professor John McCarthy has coined this term called AI. So Professor John McCarthy was basically Professor John McCarthy. And so he was a professor in Dartmouth University, US, and he has coined this term AI, and he has even defined it like simulation of a machine in an intelligent way, or something like that. He has defined it. So it was the first time when he has used this term called AI, and even he has created one algorithm, or I should say one program, which was a chess playing algorithm, which is used to play chess against human, and so on. So like he has used this term AI at first, and that's why we are saying that early 1950s, late 1950s was the birth year of AI. So it says machine learning emerged as a subfield of artificial intelligence with early work of perceptrons and decision trees. Now, uh, perceptrons you will also study further. Perceptrons means artificial neurons, and artificial neurons has three layers. First one is functional layer. First one is input layer. First one is input layer. Number one, input layer. Second one is hidden layer or functional layer. Hidden, or I should say functional layer. It is more precisely when I call it functional layer. And third one is output layer. So these are the three layers of perceptron, and that's how these three layers are defining one task which is given to perceptron, or also says as also called as artificial neuron. Now, what is decision tree? And decision tree is like one of the early algorithms which is used in machine learning. Decision tree was a decision tree where suppose that there is one statement and there are two options, yes or no, and further it is divided as yes and no and yes. So this is how decision tree is made. It was like one binary tree which contains two answers, yes and no. Okay, so this is how the machine learning was born in 1950s. Now moving on further, it is saying connectionism and neural networks. Now, what is the connectionism and neural networks? So neural networks were developed in 1980s, where uh, we are going to we were used to like create the network of perceptrons. Like if there is a one perceptron here, it looks like that only, and there was one output layer here. So it was input, it was hidden layer, and it was the output layer. So we have used this kind of the network, or I should say the number of multiple number of perceptrons, and to create like one artificial brain, or I should say the computer brain, which can perform some kind of task like pattern recognition, image recognition, and handwriting analysis, text analysis. So like these kind of programs, which so that's how we have created one like perceptron network, or I should say the artificial brain, which has used to perform some basic tasks for the AI. So that's how neural network was created at first. So neural network was basically the network of, or I should say the net of multiple perceptrons. Like there are one perceptron, two, three, and they're connected with each other, and they all give us the output on the same on the basis of same input. So that's how neural network came in. That's how the term neural network. The last one is big data and deep learning. So before moving on further on in big data has came in early 2000s, but uh, before that, since in the early 2000, when after Y2K, when at first the internet was created, like Web 2.2 came into the market, and after that, like this big data and cloud creation came into existence. Before that, there was some AI based robots as well. Like there was Deep Blue of IBM, which was basically a chess playing robot, and they have and Deep Blue has defeated Gary Kasparov as well. So that is how this is what the evolution of machine learning algorithm, and this is what the evolution of machine learning system till the date has been done. Okay, so I hope this topic is clear to you all. Now, when we are talking about different types of machine learning, different types of learning, so there are few learning algorithms which I'm going to explain you in brief. At first, there is like supervised learning, where we are using classified data. There is unsupervised learning, where the data is going to get trained, where we are not going to train the data, but instead model get trains by itself. Like in supervised learning, we give the training data which is classified. In unsupervised learning, which is we give the model a, an unclassified data, and and the machine learning model classify by itself. Then there is reinforcement learning. In the reinforcement learning, we if model performs better, we reward our model, like it contains the reward system. And similarly, there are some semi-supervised learning as well. So we will study about that further. So here are some definitions of unsupervised and types of learning. So first one is supervised learning. Supervised learning says that it involves training a model on labeled data where correct output is known. The goal is to learn mapping from inputs to outputs so that model can make predictions on new unseen data. Examples including image classification, speech recognition, and text classification. So in supervised learning, we train the model with the help of labeled data, and in this algorithm, model knows the output basically. So suppose that we have if we have to go from our home to our college, so this is called supervised learning, because we know the path as well, we know the input as we know, and we know the output. So this type of task is called as supervised learning. On the other hand, when we are talking about unsupervised learning, it involves finding pattern. Now suppose that we are in a new city and we don't know how to go to our office. So what we are going to do, we are going to find the shortest route to our office. So that is how unsupervised learning this term coined. So this involves finding patterns and relationship within a dataset without labels. So here what we are doing, we are giving the dataset which isn't labeled, which isn't classified, and we give that dataset to model to find the patterns and to classify the data itself. Like if you're talking about algorithms, some algorithms are like anomaly detection, and there are like clustering algorithms as well, and there are ensembles. So these are like some unsupervised learning algorithms which we are using nowadays. Talking about reinforcement learning. So in reinforcement learning, it involves training an agent to take actions in environment to maximize a reward signal. Now, here is the goal is to learn a policy that maps states to action that the agent can make optimal decision in a given environment. So here what happens is, if model is performing better, it will get a reward signal. But if a model is not performing better, it will get some deductions. So that is how our reinforcement learning works. And most successful examples are like some game playing algorithms and robotics as well. So like these are some different types of learning. There is another one is transfer learning, which we have studied further, where the knowledge is transferred from one model to another model. There is some semi-supervised learning, which is a mix of supervised and unsupervised learning, and that's how these learning algorithms are the part of machine learning model, which we will going to study in details in our further classes. So I guess this topic is also this is also the types of learning is also clear to you. So thank you for joining our session, and thank you for watching my lecture. Thank you so much.